Good evening, children. Today we are going to start with aldehyde, ketones and carboxylic acid. So let us begin. So here's the first question on your screen and try everyone. Let's see what the first question is trying to tell us. Which amongst the following has the highest boiling point? Right? So when it comes to boiling point, children, we need to have two things in mind. Okay? One is the nature of forces. Yeah. And the other thing that we need to keep in mind is the molar mass or the molecular mass. Yes. So both are directly proportional to your boiling point, right? The one which has a higher or stronger bond strength, okay, has a higher bond strength is going to have a higher boiling point, whereas the one which has a lesser or lower bond strength is going to have a lesser boiling point. Same goes for molecular mass. When the molecular mass is higher, we can say the van der Waals forces of attraction is more, and that is going to cause the boiling point to be very, very high. Yes. Okay. So as we can see here, this one is your alkane, right? Alkane. So alkane has only weak van der Waals forces, right? So can I say this is going to have the lowest? Yes, always alkanes have the lowest. So this is not going to be your answer. Yes. Then we have, this has dipole-dipole interaction. This can undergo hydrogen bonding, but there are repelling groups, right? Hydrophobic groups. So it's not that strong. Yes. Okay. So now here we are having alcohol, right, children? So alcohol can undergo intermolecular hydrogen bonding. Yes. It can undergo intermolecular hydrogen bonding. So can I say, children, that if here we want to find out which one has the highest boiling point, our answer is going to be nothing but alcohol, right? Yes. So our answer is going to be what, children? Answer is going to be alcohol. Yes. Okay. Moving on to the next question, children. Try everyone. I hope you all would have read the question. Okay, so let us see what's being asked here. It is telling that you have to find out what this A is and what this B is in this question. What are A and B? You have to find out, right? So as we can see, children, this here is your toluene. What? Toluene. And here you can see, children, if this reagent is there, chlorine in presence of UV, we know that it is undergoing free radical halogenation. So when it undergoes free radical halogenation, which part is it going to attack? It is going to attack your alkane part. So only this part will be attacked, right? Okay. So if this part is going to attack, we are going to erase this. So here, first of all, one chlorine will be removed, and one hydrogen will be removed, and one chlorine will be added, and you are going to have, right? Then again, minus hydrogen, you're going to have CHCl2, right? You're going to have CHCl2. Then, so here, can I see, children, that A is going to be nothing but benzene, CHCl2. Yes. Now you're hydrolyzing this in the presence of 373 Kelvin. So can I say that this is going to be benzaldehyde? Yeah. So this answer. So A is benzene with CHCl2, and this one, children, is going to be your benzaldehyde. Yes, children. I hope this answer is clear to everyone. Here, what was the takeaway point, children? That if this reagent is given to you, then you should know that it is going to undergo free radical halogenation, and this is the part where the attack is going to take place, because we are also having these positions here, and chlorine is an electrophile, so it could have gone to any place on benzene. But what's happening, children, here is that your free radical halogenation is taking place here. Yes. Okay, let's go to the next question. So next question on your screen, and try, everyone. It's an easy one. Just use a little bit of brain, and you'll be able to find out. Okay, children, I hope you all would have got the answer here. So what is the question here that is being asked? Identify the major product P in the following reaction. So you have to find out what P is, right? Okay, so here we are having benzene, and with that you have been giving benzoyl chloride, right? And that too in the presence of anhydrous AlCl3. So it's just like your what, children? A Friedel-Crafts reaction. It's just like the Friedel-Crafts reaction. So what is going to happen? HCl is going to be removed here. What's happening, children? HCl is going to be removed here. That means Cl from here, Cl minus from here is going to go, and your H is going to go from here, right? So when HCl is going to get removed, then what are you going to get, children? Now this part will be bearing a plus charge, right? So it's going to go and get attached here, right? So what is going to be the product? This is going to be C double bond O. Yeah, this is nothing but benzophenone. So benzophenone is going to be your major product. Yes. Okay, children. Let us move on to the next question. Next question on your screen. Easy one. Try, everyone. Okay, children. So let's see what's the question that's being asked here. You're being asked to identify the name reaction, right? So what name reaction is it that we have to identify? Now, is this reaction Stephen reaction, children? Is this reaction Stephen reaction? No, this is not Stephen reaction, right? Okay. Is this reaction Itard reaction? No, because in case of Itard reaction, you are going to have at least toluene is the starting. Yes. Then, is it going to be Rosenman reaction? Is it going to be Rosenman reaction, children? This is not going to be Rosenman reaction. Why? Because in case of Rosenman reaction, children, what do you have? You have, okay, what do you have, children? You have CHO, right? You have CHO. That is, you are going to see next, okay? And what is your reagent in case of this? Okay, you have palladium BaSO4, and with that you have hydrogen as the catalyst. You are having hydrogen as the catalyst. This is not the reactant. Okay. So what do you have, children, here? Although the products are same, so in Rosenman reaction also you are going to get aldehyde. Yes, in Rosenman reaction also you are going to get aldehyde. But what is going to be your reagent, children? You are going to have PD with BaSO4, right? This was your reagent. But is this that reagent here? That is not the reagent here. The reagent here is CO, HCl, anhydrous AlCl. This is nothing but your Gutterman-Koch reaction. So what is the answer going to be here, children? Your answer is going to be Gutterman-Koch reaction, right? So even if you didn't know directly, you need the other reactions, you could have identified and eliminated the options by using their reagents, because reagents are very specific for different kinds of reactions. Yes, okay. So is there any other doubt here, children? Should we move ahead and see? Let's go to the next question. So next question on your screen. So let's see what's being given here. It's given here that when M-chlorobenzaldehyde is treated with 50% KOH solution, let's write M-chlorobenzaldehyde, right? This, children, is a benzaldehyde. This is a benzaldehyde. And at this position, you are having chloro. So this is your M-chlorobenzaldehyde. Yes, children. Now, this thing is being treated with 50% KOH solution. Yes. So when this is treated with KOH solution, what is going to be your product? What are going to be your products? Now, you have to identify that if this is KOH, what are the possibilities or what are the possible reactions that could happen with KOH? We can have substitution. We can have elimination. We can have aldol condensation. We can have Cannizzaro reaction, right? Cannizzaro reaction. Now, can I say, children, that it is not a nucleophilic substitution reaction, because there is nothing we can use to substitute here. So substitution is eliminated. For KOH, we need at least alcohol for elimination. So can I say elimination is also eliminated, right? The next thing that we have on plate here is, what do we have, children? We are having aldol condensation. Yes, so aldol condensation occurs in those which have an alpha hydrogen. Now this is your main carbon, so star carbon. Yes, this is your star carbon. The carbon next to your star carbon is your alpha carbon. Right? So can you tell me how many bonds are there already? 1, 2, 3, 4 bonds. Already 4 bonds are present. So can I say there is no alpha hydrogen here? There is no alpha hydrogen here. If there is no alpha hydrogen, so this is also not going to undergo. So we are not also going to have aldol condensation here. So we are left with only Cannizzaro reaction. We are left with only what reaction? Cannizzaro reaction. And what happens in case of Cannizzaro reaction, children? So we'll eliminate all of this. Yeah, so we understood that here we are going to have Cannizzaro reaction. Yes, okay. So Cannizzaro reaction we are going to have here. So in case of Cannizzaro reaction, in what cases do we have Cannizzaro reaction? Cannizzaro reactions occurs in that, okay, where there is concentrated base, right? So 50% KOH is concentrated, so that is correct. Where there is no alpha hydrogen is present, that is also the case here. And what happens here? So here it's aldehyde. Okay, so aldehyde is going to undergo what kind of disproportionation reaction here? That means one step higher and one step lower. That means it will give you two products, one with alcohol, so it is getting reduced, and one more will be oxidized, so it is going to be COOH, so it is going to be oxidized. So it is going to give you two products. It is going to give you two products. Yes, so now this is CHO, right? CHO. So when this gets converted into alcohol, so what are you going to get, children? You are going to get a benzene ring. CHO becomes CH2OH plus, then what do we have? It gets oxidized as well. So when it gets oxidized, you have COOH, right? Okay, so this is going to be your answer. This is going to be your answer. So where is it present, children? As we can see here, something normal aldone condensation is given. This is wrong, this is wrong, okay, and this is again wrong because here OH is there. From where does this OH come? This is not required, so this position is correct. Cl is in its own position, only this part one has undergone oxidation and other part has gone reduction, right, children? Okay, so can I say that this one is your correct answer? Okay, so this one is going to be your correct answer, children. Yes, okay. So I hope you all understood why did it undergo Cannizzaro reaction, why it didn't go aldol condensation or substitution or elimination or any other reaction. Yes, okay. I hope it is clear with this. Okay. Let's go ahead and see the next reaction. So the next reaction is on your screen and we have already discussed this kind of reaction. So try, children, and let me know the answer. Okay, so I hope you all would have read the question, and let's see what's given here. Again, the question is asked that what kind of reduction is this? So we are having acid chloride here, right? So let us write down this reaction. So this, children, is your benzoyl chloride. Yes, and we are using H2 and we know that this is a good reducing agent, right? This is a reducing agent. Yes, children, this is a reducing agent. Okay, so that's why the question is a reduction reaction. So anywhere there is reduction is not written, that would have been the answer, but everywhere here reduction is written, so we cannot take away that point here and cannot use that as a trick, right? So this is going to be a reducing agent, we know that. Now, children, what is this PD and BaSO4? This PD is used as a catalyst in this reaction, because we know in general we use hydrogen with nickel, palladium or platinum, right? Okay, so this is being used as the catalyst. And what is the work of this BaSO4, children? This acts as your poison. This acts as your poison. That means it should have been reduced to this much. After this, as this is a good reducing agent, there would have been further reduction. There would have been further reduction to CH2OH, right? But this doesn't happen. Why? Because the rate of reaction slows down due to the presence of this poison. and this is nothing but your BaSO4, which reduces the rate of reaction. Yes. So due to the reduction in rate of reaction, we are able to get this as a major product. This as a major product. Okay. So is this Wolff-Kissner reduction? No. Why is this not Wolff-Kissner reduction? Because in case of Wolff-Kissner reduction, anywhere where there is C double bond O, this converts into CH2. This converts into CH2. And we see that here C double bond O is not changing. Here also we are having C double bond O. Yes. How C double bond O? Because CHO, we know that we can write it like this. So I hope there is no doubt here. So C double bond O gets converted into CH2 here. Yes. And IIT reaction, we know that also leads to the formation. But here we use toluene. Yes. So that is also not here. Then Stephen reduction, we know that this is not the case here. Yes, it needs cyanides for the reagent, okay, for the reactant. Then we have Rosenmund reaction. So our answer is going to be what, children? Rosenmund reaction. So this reaction where the acid chloride gets converted into aldehyde in the presence of hydrogen and palladium and BaSO4, that reaction, children, is nothing but your Rosenmund reaction. So this one is going to be your correct answer. Yes, so this one, children, is going to be the correct answer. Yeah. Is it clear? Okay. Let's move on to the next question. So next question on your screen, I'll be invisible. This was actually asked in JEE Mains 2024, and it's a very, very easy question. Yes. So just to show you that these kind of questions are also being asked, so try this one. So again, the next question on your screen here. So what's being asked here, children? You've been asked that the molecular formula of the second homologue in the homologue series of monocarboxylic acid. Monocarboxylic acids means, children, you'll have one COOH group here, right? Okay. So what's the formula of the first carboxylic acid, children? We know that it is formic acid. Yes or no, children? It is going to be a formic acid. So when formic acid, we have the formula HCOOH. Right? The second acid, or this is otherwise known as methanoic acid. The second is your ethanoic acid, which is otherwise known by the name acetic acid. Vinegar, yes, that is 2 carbons COOH to fill the valency. This is the formula. Yes or no, children? So we see that we have 2 carbons here, 4 hydrogens here, and O2 here, C2H4O2, right? And that is present in option A. So see how easy questions are being asked. So if your shift is a bit lucky, you can end up with very easy questions. Okay. Let us move on to the next question. Okay. Now try this, everyone, children. Okay. This might be a little bit tricky, but not at all difficult. Try. Okay. So let's see, children. Okay. So let us analyze this question. How is this going to work? So we will see all the reagents here and we'll be cancelling whatever is not working out for us. So if we see, we have CH3 and KMnO4 is definitely a strong oxidizing agent. Yes, children? So if we are having CH3 here and you give KMnO4, it's going to oxidize, right? And this is going to become COOH. Then you're having bromine. Now we know that this one is a minus R group. As it is minus R group, so you're going to have your product at meta position. But here it is in ortho position, right? So is this correct? So this is definitely going to be wrong, right? Now, this is Fe in presence of H plus. Fe in presence of H plus, right? So we know that, children. Here we are having CH3, we are having NO2. So when this undergoes, this is a reducing agent. H plus is nothing but Fe in presence of, just consider HCl. So we know that NO2 will get reduced because this is a good reducing agent. So this is going to be CH3 and H2. Okay. Then we have HNO2. So this, children, is going to undergo diazotization. When it undergoes diazotization, you are going to have N2Cl. When you have N2Cl, this one, children, is going to get converted into CuCl. So here you will have chlorine. So as of now, all good. Okay. Then we have KMnO4. Now if you give KMnO4, this one is going to be COOH. Yes. Then you have Br2. So here your bromine is going to come. Everything was fine. Just what happened? If we would have reversed these things somehow, then things could have worked out. But here bromine is going to be in second position. So that's why this is also going to be wrong. This is also going to be wrong. Right? Okay. Let us look at the third one. Okay. So I'm explaining this, that's why it's taking a bit long, but this shouldn't take you more than a minute or less. Let us look at the next one, children. If we are having CH3 NO2, you are giving Br2 and Fe. So with respect to this, it is going to go in meta position, and with respect to this, it is going in ortho position, which is nothing but here. So here you are going to get bromine. Yes, so the first reagent is done. Fe and H plus. So what will happen? This one is going to get converted into NH2. Reduction is going to take place. This one also okay. HNO2. Then what's happening? This is going to convert into benzene N2Cl. Okay, all right. Then CuCl. Then what's going to happen? Again, this part is going to get converted into chlorine. Yes. As of now, all right. Then we have KMnO4. This is oxidizing agent. So what it's going to do? Now it's going to convert this part, and you're going to get COOH. So can I say that we got this right from this one? So this is going to be your correct order. Let us check for the last one as well. So Br2Fe. Br2Fe, if we see, with respect to this, we are going to get at this position. Okay, no issues. FeH plus, this one is going to be NH2. Then KMnO4, this is going to be COOH. Then Cl2, children, it's going to come here. Cl2 is going to come here, and we don't need Cl here, we need Cl at the end, right? So this is going to be wrong. So your option is going to be option 3. Yes, not at all difficult, but a bit tricky, right? Okay. So I hope this is clear to everyone. Yes? Okay. Let's move on to the next question, children. So next question on your screen, and try everyone. Okay. So next question on the screen. Let's see. So what do you have, children? You have this big compound. So that's what you do. You get scared when you see a big compound and you make mistakes, whereas it's a very easy one. It's nothing but your acid, right? Okay. So you're having SOCl2. Yes. So it's not going to do nothing, but it's going to just remove this OH for you and get you a Cl. Halogenation, kind of, right? Yes. Now what do you have, children? You have RNH2. Can I say that HCl is going to get removed from here? Yes, HCl is going to get removed from here. So when HCl gets removed, children, what are you going to get? You're going to get NHR, right? You're going to get this. Okay, now this is done, this is done. Yes, and now you have LiAlH4, which is a nothing but very strong reducing agent. Yes, so what is it going to do, children? It's going to make this way, right? Okay, so this is going to be your product. Yes, okay. Now there's one question. If I give you two options, this and this. Okay, tell me in the comment section, this is a homework for you, that which one is going to be your product. Because what did I do? I have removed the double bond here, and I haven't removed the double bond here, but here I have removed the double bond, right? So you're having two cases here, so you need to find out that which one is the correct answer, how specific this is, and you have to tell me in the comment section that between 1 and 2 which one is going to be your product. Yes, okay. So that's it for today, children, and we'll see you in the next class with some more questions and some more concepts. So until then, take care, children. Bye bye.